All right, hello you guys, making the review here 4.1 to 4.3. So let's get into it. So the first one's asking us to graph these exponential functions. Okay, so it says to graph the functions, include x values of -1, 0, and 1, similar to how we did it in class. Um, so we're going to figure out what is y when x is these. And so the equation we're dealing with here is 3 to the x. So again, it's kind of if 3 was raised to each of these exponents, what would we get as an answer? Okay, so 3 to the -1, again, those negative exponents can be tricky. Again, the rule is there we kind of take the reciprocal of the base, right? So 3 is the base, so 1 over 3 to the first power is kind of how we deal with that. Negative exponent, make it positive. And 1 over 3 to the first is just 1/3, right? So that's our first point. Second point, 3 to the 0. Anything to the 0 is 1, right? So 0, 1. And then 3 to the first power is just 3, right? So there's our 3 points, okay? We found that. We've got them in the table. And then it says you must label the points from your table on your graph as ordered pairs. Okay, so let's do that. So we got -1, 1/3. That's our first point. Second point, we've got 0, 1. And then our third point, we've got 1, 3. Okay. So there we go. There is our first graph, okay? And in this graph, we don't have any transformations or anything. We're going to deal with those. So this kind of in and of itself would be almost like a parent function, kind of like we saw in class. So we look at this, and yeah, the horizontal asymptote here is just going to be at y equals 0, or the x-axis, right? That's kind of where it flattens out here as it goes to the left. Now, in number 2, y or f of x equals 1/5 to the x power. So same idea, we are going to make our table with those -0, -1, 0, and 1 points. And now we're thinking, what if we raised 1/5 to the exponent that is each of those x values? So 1/5 to the -1, again, kind of the rule there. We take the reciprocal of a negative exponent, and what that does is flips it around, so that would be 5 to the first, or 5 over 1 to the first, right? And so that would just give us 5. 1/5 to the 0, again, anything to the 0 equals 1, and then 1/5 to the first power just equals 1/5. So there's our 3 points here. And so we're going -1, 5, label that, 0, 1, and 1, 1/5, so just above the x-axis. There we go, okay? And we see this is going sort of like that. Kind of the opposite, right? Comparing that to number 1, right? This is and again, we named these, right? This is an exponential decay. That's what happens when this base is less than 1. And this is an exponential growth when our base is higher than 1. Our horizontal asymptotes also is y equals 0. Even though it's curving the other way, it's still flattening out here just as it goes to the right. So approaching that y-axis, but never quite getting there. Okay, good. All right, guys, so now we're dealing with problems 3 through 7, and I'm sorry I didn't leave you a ton of room to work these out, so I have a separate piece of paper. And so what we're going to do is we are going to convert these, right? The first 3 and 4 just ask us to write the logarithm equation as an exponential, and then 5 and 6 vice versa, going from exponent to logarithm. Okay, and just remembering kind of our template for that, right? We said if we had b to the x equals y, right? How we would write that, again, remembering my slogan with these, the answer to a logarithm is its exponent, right? So we could say x equals, or I guess I'm seeing these multiple choice answers kind of have it the other way, so let's go the other way. So log base b of y equals x, right? When we solve a logarithm, what we're trying to find is, so log base b of y equals x, we're trying to find b to what power equals y when we solve a logarithm, right? And so we're looking at number 3, right? Log base 4 of 64 equals 3, right? So if I write that out, again, it's just kind of matching it up with my template here, right? So I'm given the logarithm version, so then it's just matching it up here. So this is be saying base is 4, the exponent is the answer to the logarithm, right? So that would be 3 equals 64. And again, for these, they should make mathematical sense, right? 4 to the third, 4 times 4 times 4, does equal 64, right? So that, and that's actually the only one. That's true. That's a good way to check your answer, okay? None of these other ones are actually mathematically true. And then same with number 4, log base 3 to the 9 equals x, right? It's a little harder. We're not able to check this one mathematically. I didn't notice that the first time because of that x. But again, just kind of, we see it there, log base 3 of 9 equals x. So the base is 3. The exponent is the answer to the logarithm, so the exponent's x, and then the answer is 9, right? So 3, that would also be b, 3 to the x equals 9, right? So there we go. Okay, now looking at 5 and 6, 2 to the third power equals 8. So now we're going the other way, writing that as a logarithm, right? So again, we can kind of refer to our template up here, 2 to the third equals 8. Okay, so again, we're going to write log. Our base is our number being raised to the exponent, so 2. The number here is easy to mix up. The number here is the answer to the kind of exponential version. 2 base 2 of 8 equals 3. The answer to a logarithm is the exponent. Okay, so log base 2 of 8 equals 3. And so the answer to that one, matching that up, would be letter C. All right, and then number 6, 7 to the third power equals x. So looking at that, right, matching it up, log base 7, right? 7's the base. X is the answer to the exponential. 3 is the exponent. Okay, so log base 7 of x equals 3 is what I'm looking for. And you see that would be letter D. Okay, so there is our first few problems. Let me flip over. All right, so here looking at number 7, we are asked to graph both the parent graph and the logarithmic, or sorry, excuse me, the parent graph is a logarithm, but we're doing these transformations here, right, where we graph this and graph the parent and then see what the transformation is going to look like. So again, guys, in class, what I recommended is, if you know your transformation rules, that's helpful, but you can use your calculator to help you with this version, okay? And again, the problem that some of you might be having is you might not be able to get that log base, right? That log base is what we need to use. So you can get there by going math, by pressing the math button on your calculator, then scrolling down like 10 times till you get to log base. That's how we can type these in. Okay. If you're not able to do this in your calculator, go on Google Classroom. There's an app that really helps, has a calculator with, or an app that serves as a TI calculator that is able to graph these for you. Okay, so parent graph, log base 2 of x. So again, just kind of thinking about this, x, y. So again, guys, with a logarithm, we're kind of working backwards in a sense. So when we're picking these x values, the x values aren't the exponent like they are for an exponential version. The exponent would be, for the x values here, would be the answer, and the y value is going to be the exponent, okay? So that's almost what we're going to be dealing with. So we're going to kind of say, here's our base for all these. The x values are going to be our answer, and the y value would be the exponent, okay? So look what I'm going to do. I'm going to choose an x value of 1/2. I'm going to choose an x value of 1, and I'm going to choose an x value of 2. Okay, a little bit different. And again, you can use, what I would recommend too with these, you can use your calculator if you have trouble with the parent graph to just locate some key points. They don't have to be these in particular, right? Because in the directions, it doesn't specify the 3 x values that you should choose, so it doesn't have to be these 3. But again, we think, okay, 2 to what exponent would equal x, right? And again, you can use your calculator. So, but that would end up being -1, right? 2 to the -1 power would end up giving us an answer of 1/2. So again, kind of working backwards. We think, okay, 2 to what exponent would equal 1, okay? And that would give a 0, right? If the exponent was 0, right, that would result in this 1 here, right? And then 2, right, 2 to what power would equal 2, and that would equal 1, right? So again, if you have trouble with this, that's kind of what the thinking is there for the last one. 2 to what power would equal to, again, the x value is the answer, and you work backwards then to think what the exponent would have been to result in that, okay? But these are 3 points that we have, okay? So 1/2 comma -1, 1, 0, and 2, 1. If you remember graphing logarithms in class, this is how we did it as well right here. Okay, so there's our parent graph. And again, if it asks us to label the asymptote, what we should do, because again, it says label 3 points and an asymptote on both the parent graph and, sorry, there's a typo there. But yeah, we should label these. We should follow directions as best we can. So we have the table there. So 1/2, -1, we've got, I guess that's this point. this point 1, 0, and then this point 2, 1. Okay, so again, if you know your transformations rules, it's very helpful, okay? If not, use your calculator like I said. But here, if we're making a table, it doesn't necessarily ask us to make a table, but what is going to end up happening from this parent graph is this plus 2 is in this group with the x, so that means we're going to shift all the points left 2. Again, a number added or subtracted in a group with the x denotes that it's a horizontal change, and a plus 2 in there denotes that we're moved specifically to the left. So all the points, and if it helps you sketch the parent graph on this one too, so you can kind of use that. But we have it over here too. So if this original point was at 1/2 -1, if I bump that over 2 spaces to the left, that's going to change my x value to -1.5. The y value doesn't change with the horizontal shift, just the x value went from here 2 spaces over to here. So that's going to be -1 and 1/2, or -1.5, comma -1. Okay. This point right here, a little easier because we're not dealing with fractions. So 1, 0, bump it over 2 to the left. Now I'm at -1, 0. And then this one that was at 2, 1, bump that over 2 to the left, would give me 0, 1. Okay, so there's my graph. And again, it's a good idea to look at this in your calculator as well, just to get an idea of what the rest of it looks like. But yeah, it's basically the same thing, just all pushed over to the left. And you remember, right, we said that for this one, it had a vertical asymptote of, right here on the y-axis, vertical asymptote of x equals 0. But here, right, when we shift this graph, we bumped all the stuff over 2 points, 2 spaces to the left, right, everything. And that includes also, we're going to move over that vertical asymptote over 2 spaces. So normally the vertical asymptote is going to stay at 0 unless there's one of these horizontal changes, one of these horizontal shifts. So vertical asymptote now would be at x equals -2. Okay. Again, I do this without a calculator, but you can just go into your calculator, type this in with log base, okay, and see, go to your table and see where these points are too. Okay, I apologize for not having a calculator here to show that, but hopefully you can follow along there. Okay, now this one says, number 8, there we go, graph the functions in the same rectangular coordinate system. I guess that's this, I've never heard it called that. Rectangular specifically. Label 3 points from each function on your graph. Okay, so same as above. Make a table of values with 3 points for each graph and list the domain and range for each function. Okay, so we did this in class 2. This, I think, was exactly actually one of your homework problems. So we look at this, okay, again, exponential and logarithmic, comparing these two. Again, what we said about these graphs is that they're inverses, meaning they are going to be pretty much exact. Like, we're going to see a lot of similarities, but everything's kind of flipped, okay? So for this exponential graph, what does it say? Label 3 points, okay? So if I just do -1, 0, and 1, okay, again, that's kind of the same as the first couple graphs where I look at this and I think, okay, 5 to that exponent, what would that equal? Okay, so 5 to the -1 power would be 1/5. 5 to the 0 power would equal 1. 5 to the first power would equal 5. Okay, so my exponential graph would look something like this. Okay, and again, I can label those points. And again, lastly, it says, you can write your asymptote there. It doesn't ask for that, so I'll skip it. And then just domain and range. So thinking about, right, domain and range from left to right, this will, right, it's going to go forever to the left this way. This, it looks like it might be similar to an asymptote, but it never quite is going to flatten out like an asymptote would. So domain's going to be -infinity to infinity. But then the range, right, it is going to go up forever this way, but then it is not going to go any lower than 0, right? 0 is the location of this horizontal asymptote, so I can say 0, infinity for that, okay? So then knowing that these are inverses, again, so when you make your table for the logarithmic graph, again, you don't really have any work to do, because if you know they're inverses, like they are, we can just literally just write these same numbers except in the opposite column from where they were. So for the x values, I can do 1/5, 1, and 5. For the y values, I can do -1, 0, and 1, okay? So think about how that would look. X is 1/5, so that's just barely over from the origin. Y is -1, so that would put me down here. X is 1, Y is 0, so that puts me right here. And then 5, 1 puts me right here. Okay, so again, a logarithmic graph, like a flipped around version of the exponential graph. Okay, again, this would have a vertical asymptote at 0, like we just said, and then the domain and range too. Domain is going to be, again, it's just kind of taking these and flipping them as well. So the domain is going to match up with this range, 0 to infinity, because again, it's going to go to the right forever, but it is not going to go any further to the left than 0. That's where that vertical asymptote is. And then the range, yes, it will go down forever, and then it's going to very gradually continue to go up here. So negative infinity to infinity for the range. Okay, so that can be tricky for sure, but again, you've got your calculator to graph those if you need. All right, now shifting gears, compound interest. Okay, so now we're dealing with, and it gives you these two equations. You'll definitely have these on your test. So you have this, okay? It's the first one says, find the accumulated value of an investment of $5,000. Again, so that's going to be your principal, okay? Your P, okay? At 5%, that's your rate. But again, remember for your rate, we write it as a decimal, so 0.05. Compounded monthly, what does that mean? That's your N value. That's how often, how many times in the year that it's going to compound. That would be 12. And then 8 years, that's going to be your T, okay? So for this, and again, we're not going to worry about this second equation unless we see this word right here, compounded continuously. So that's going to be the second one. But if it's compounded monthly or weekly, bi-weekly, or semi-annually, whatever, whole bunch of words using this first guy here. Okay, so let me get my piece of paper. Okay, so if we're dealing with these values, okay, so putting them in this equation. So that's just A equals 5,000 times 1 plus the rate, 0.05, over how many times in the year it compounds, so 12. And then we got n times t in the exponential position, so 12 times 8, okay? Let me get my calculator, and you can just type all this in your calculator and it can solve it for you. All right, guys, so I found my old TI calculator from when I was in high school, so you can see it's old. It doesn't have all the fancy functions, but it'll help us do this one right here. All right, so anybody else with an old calculator, you see we can't do the fancy like alpha y equals to get the fraction in there, whatever, but it worked out, and so we got 7,452.93. Okay, and then you see that matches up with answer A here out of my answer options. So we're going with A for number 9. Okay, how about number 10? Find the accumulated value of an investment of $2,000. So again, there's P at 7%. There's my rate. Compounded continuously for 4 years. There's my T. And again, you might be thinking, where's your N value? You don't have one, right? You look at your continuous compounding equation, no N in there, right? Because compounding continuously means we're not doing it at a specified amount of times throughout the year. It's kind of more continuous and ongoing. Okay, so putting all those into an equation, okay, so we have A equals 2,000 times E, remember E is that constant value, okay, and then 0.07, putting that rate as a decimal, and then time is 4 years. Okay, put that in my calculator, 2,000 times E, again, you get E down here with your second ln, right? You see the E to the X right there. So second ln e to the 0.07 times 4 power. Put that in parentheses. So 26, 46, 26. There we go. Answer A there as well. Yes, 26, 46, 26. Very fun. Okay, lastly, suppose that you have $2,000 to invest. Which investment yields the greater return over 7 years? 6.25% compounded continuously. So again, using that second equation for that. And then, or 6.3% compounded semi-annually. Okay, so again, we're going to have to do both of these to see which one is bigger, right? So let me work that out real quick. All right, guys, so I'm just finishing writing these. And again, semi-annually means twice during a year. So your N value is going to be 2. Your time is 7. Don't forget to put your rates as decimals too. And there's 2 different rates. Don't use the same rate for each one. 0.625. 0.0625 and 0.063 for that, okay? So I'll put these in the calculator. Let's get our answer. So I'm getting 3,097.66 for the continuous. And I'm getting 3,087 $45 for the semi-annual. So what do we see? We see that continuous would give us about $10 more than the semi-annual. Okay, so we would want to choose letter A there as well, right? So the compounded continuously yields the greater return, aka we'll get more money. Okay, so A, and A for 9, 10, and 11. All right, guys, lastly, our stuff we've been working on recently using these properties of logarithms to expand and then condense. Okay, so again, properties, we got the product rule, we've got the quotient rule, we've got the power rule. Okay, so looking at these, okay, log base b of y times z to the fourth. Okay, so if we're expanding this, we look and see what's happening within, what's happening log base b of y times z to the fourth. What's happening within the parentheses? And I would say there's multiplication, right? Y times z to the fourth. Okay, and so again, you remember your product rule says that if it is written, like if you had a log of x, y, we separate it out into two separate logarithms, but the key there is that we are adding. Okay, so we look at this, and I see that there's this 4 exponent here. We do not deal with that first here, okay, because the exponent, if it applied to both variables, we would, but it's only applying to the z, so we're going to deal with that in a little bit, but let's just separate it using product rule first. So that's going to be log base b of y plus log base b of z to the fourth. Okay, and now you look at this, right? Now this one's fine. This first logarithm's fine how it is. We don't need to do anything else there. Just this one has that 4 exponent, right? So that, you remember our power rule, that 4 is going to come out front. So we can write our final answer as log base b of y plus log base b of, plus 4, right? That 4 comes out front. 4 times log base b of z, right? So that's expanding it, right? Using that power rule, taking the exponent to the coefficient spot, that's considered expanding it, right? And so you see letter B here matches with that. Okay, so we got B there for number 12. Number 13, log base 3 of 7 times 11 over 5. Okay, lots going on in here, okay? This, we see two separate things happening, and I said in class 2, don't be a hero, don't try to do it all at once. What I notice, there's one thing in this denominator, okay? So what I can do is kind of say first, log base 3 of 7 times 11 minus log base 3 of 5. What happened there is I use the quotient rule to just separate this, kind of get rid of the fraction, say these two can remain multiplied. These were in my numerator, this is in my denominator. So that's how we split up using the quotient rule. Okay, and then, right, I can still separate this first logarithm into two separate ones as well. Log base 3 of 7 plus log base 3 of 11 minus that log base 3 of 5. I'm getting into my answers here a little bit. But there we go. So that is it, all separated out. And you see that letter B is the only one with those 3 separate logarithms. We cannot combine these, okay? We cannot combine these like they try to do for letter D, or kind of multiplying here like they do for A. Okay, you remember what a logarithm means. A logarithm is kind of asking us for an exponent, right? So like if we were to combine these here, or like what this is really saying is the exponent that you'd raise 3 to get 7 plus the exponent that you'd raise 3 to equal 11 minus the exponent that you'd raise 3 to get 5, right? These are all exponents, right? So it's kind of weird. They would all be like 1 point something. This one would be 2 point something. So again, it wouldn't really, like, they're not going to equal the same thing here. Okay, so letter B is going to be the way to go there. Okay. All right, 14. Log base 4 of x to the 4th over y to the 7th. Okay, so again, just very simpler than what we had, right? Just two things divided here. So I can separate those. Log base 4 of x to the 4th minus log base 4 of y to the 7th. Okay, so there we go. And again, what we're dealing with here is we have things with exponents still, right? We have things with exponents. So what I can do is bump those out and make those both into coefficients, right? But it's important to do the power rule or the product rule or quotient rule first before we deal with that. Because you remember, when we condense these that we'll do down here, that's the first thing we deal with, right? Because we're exactly reversing the process. So we're going to be dealing with the coefficients here first, whereas here we kind of deal with them last. Okay, so 4 times log base 4 of x minus 7 times log base 4 of y. Okay, so you see which one matches with that would be letter A. Okay, so there we go. Product or quotient rule first, then dealing with the exponents when we are expanding. Okay, lastly, number 15, log base 5 of x minus 8 over x to the 8th. Okay, so again, quotient rule, I notice that there's a fraction here, so I want to separate this denominator from the numerator. So log base 5 of x minus 8. Now that's a group, and it's okay that these are subtracted, right? We saw some of these in class. So just keep it like that, log base 5 of x to the 8th. Okay. So guys, this first one's going to remain the same. You look at your answers, most of the answers still have that like it is, okay? Now, what they don't get caught up with letter D though, because look, in letter D they try to move the 8 out like it's an exponent, but we don't do that with this minus 8. That's definitely not D. But then so look at this exponent, right? We got 8. Going to bump that out to the front as a coefficient. So log base 5 of x minus 8 minus 8 times log base 5 of x. Okay, so hopefully, yeah, 2 different lines there, but that's kind of log base 5 of x minus 8 minus, so our answer here is going to be B. Okay, that has it written the right way. And be very careful, right? The letter C says the exact same thing, just plus instead of minus. So make sure you look carefully over these answers. All right, guys, almost done. Looking at 16 through 19. Okay, now we're going the opposite way. We are going to condense, okay? We're condensing these down into a single logarithm, okay? So again, the first thing you want to deal with here is deal with those powers, okay? If you see a coefficient, you want to move that back into the exponent position. We can't condense everything down until we do that. So we want to deal with this 1/2 for this one. So if we do that, it'll turn into log base 8 of x to the 1/2. Again, we said remember to, and that's is why it's important, guys. Look at how your answers are written. They're written as radicals. Okay, so that's why I said it's important that we remember that this 1/2 is the same as radicals. So let's even rewrite that like right now. Log base 8 of square root of x. So then next we have plus log base 8 of y. Okay, so again, now I look at this, I dealt with my powers, I'm all good, and now I want to look at this and I think, okay, what do I use, product or quotient to combine these into one? And again, that key there is what sign it is. So that's a plus, so that means product rule. So log base 8 of square root of x times y. Now keep in mind, this isn't the square root of y. This y doesn't have a 1/2 exponent. So like look at letter B, if you can see it between all my writing. That y is under a radical, okay? So not answer B. And they changed the order on you here, but letter D ends up being the answer, right? Because look, the y is not in the radical, the x is, and they're being multiplied. Okay, so we're going to go with letter D for that one. All right, number 17, 6 times the natural log of A minus 9 times the natural log of B. 2 coefficients, okay. Let me use my other piece of paper. That's just going to be easier. Okay. So the first thing I want to do here is, again, move these coefficients up to being exponents, right? So that turns us into natural log of a to the 6th minus, natural log of b to the 9th. Okay, so there we go. Made these into exponents. And now I think product or quotient rule to combine these, and it's going to end up being quotient because it's a subtraction, right? So natural log of a to the 6th over b to the 9th. Okay. Now let's look over again. They give you answers that are really similar, right? When we condense, our answers should be a single logarithm. Okay, it says it up there in the directions. So like look at letter C. Some kids might try to choose letter C. That has double natural logs. I want my answer to be just a single one, right? And so A ends up being the answer. Okay, not D because again we can't combine these exponents at all. Okay. and not B because, look, they didn't change these to be exponents. They wrote them as coefficients still instead. So letter A for that one. All right, guys, just two more. 18, 7 times natural log of x minus 4 minus 8 times natural log of x. Okay, so again, two coefficients. Let's deal with those. Bump those up to be exponents. Okay, so natural log of x minus 4 to the 7th. Okay, and here's how I wrote that in class, kind of double parentheses. This whole group, don't write x minus 4 to the 7th like this, okay, because it's the whole group that's being raised to the 7th power. So where you'd want to write it like this. And then minus ln of x to the 8th. Okay. So there we go. There is first step, dealing with coefficients. And then second step, again, how can I combine these? Quotient rule again, right? So natural log of x minus 4 to the 7th over x to the 8th. I can't cancel these x's. This x is kind of locked in this group. I can't reduce this at all. So our answer should just be one of these, right? And we see here it's letter A again. Okay, so x minus, and they don't put the natural log. Like what I prefer to do is put the extra parentheses there, but they don't do that. So that's fine. So letter A again. Alrighty, last one. We see a big guy here, right? So look at your signs. Your signs separate your logs, but I have three logs. Log base A of Q, log base A of R, 3 times log base A of P. Okay, so only one of these has a coefficient. Okay, so if you move that up, again, all the other logs are the same. So log base A of Q minus log base A of R plus log base A of P to the third. Okay, so again, that just this P is being raised to the 3 exponent. So our answer, look, our answer should just have P cubed, right? So we know it's not going to be C. That's not even a 3 exponent. Now, again, don't be a hero. Don't try to combine all these at once. Go nice and slow, okay? So log base A of Q, log base A of R. Again, I can just ignore this one even. And I just think, okay, how can I just combine these two into a single logarithm? And quotient rule, right? Subtraction. So log base A of Q over R is how I could write that. Okay. And then plus log base A of P cubed. What it ends up being is, again, this we're going to combine these with product rule, okay? This P cubed is going to be multiplied by this fraction. So you could write that as Q over R times P cubed, okay? How it ends up being written in your multiple choice answer is, what you can also do is kind of bring this up and be with the Q up here. So Q P cubed over R. Okay, and again, looking over our answers, A is what we're going to go with. The only one that might be kind of close there is letter D, right? They put the P cubed down with the R, okay? But if it was minus this, minus this, minus that, that would be the answer. But because it's being added, we combine it with product rule, put it up top. So A for that as well. All right, guys, hope that was helpful. Thanks so much. Let me know if you have any other questions or anything at all. Bye-bye.